So here is another question on temperature measurement and temperature scales. So it is given that a platinum resistance thermometer, it reads 0 degree and 100 degree in Celsius at the ice point and boiling point of water respectively. Information is given that the resistance of the platinum wire, which is used in this platinum resistance thermometer, it varies with Celsius temperature theta as R subscript T, which is the resistance at particular temperature theta, which is equal to R0 into 1 plus alpha theta plus beta theta square, where alpha and beta are the temperature coefficients of resistance for this platinum wire. Alpha is 3.8 into 10 to the power minus 3 per degree Celsius, and beta is minus 5.6 into 10 to the power minus 7 per degree Celsius squared. Then it is asked to find out what will be the reading of this thermometer if it is placed in a liquid maintained at 50 degree Celsius. Okay. So let us solve it. So if you remember, we discussed that for a platinum resistance thermometer, the temperature is a function of the resistance, which is governed by the relationship which is given. So it is given by T is equal to RT minus R0 by R100 minus R0 into 100. So basically the equation is something like this. The general equation is something like this. Okay, RT minus R lower fixed point by R upper fixed point minus R lower fixed point into the difference of temperature between the upper fixed point and the lower fixed point. So here for Celsius scale, this is the general equation for the temperature. So here, if we want to determine what reading it will give us at 50 degrees Celsius, so this RT will be equal to R50, this. So here we will substitute the values. We'll be using the information which is given, where RT is equal to R0 into 1 plus alpha theta plus beta theta square. Okay, this. Now at T equals to 0 degrees Celsius, or theta is equal to 0 degrees Celsius. So here R0 is equal to R0 into 1 plus alpha into 0 plus beta into 0 square, because theta is 0 square, so it is basically R0 into 1 plus 0 plus 0, so it is equal to R0 simply. Okay, that. Then R50, resistance at 50 degrees Celsius. R50 is equal to R0 into 1 plus 50 alpha plus 50 square beta. Okay, this. And R100, the resistance at 100 degrees. We are all using this relationship. Okay, so this is given RT, but it's actually R theta. You can also substitute it as R theta, because theta is the Celsius temperature. Okay, R theta. So R100 is equal to R0 into 1 plus 100 alpha plus 100 square beta. In place of theta, here we have substituted 50. In place of theta, here we have substituted 100. So these are the values. Now we'll make the substitutions. So here RT is R50. So here if we substitute the given values, the temperature reading will be R50 minus R0 by R100 minus R0 into 100. Okay, so that is equal to, it's coming, R50 is R0 into 1 plus 50 alpha plus 50 square beta minus R0 by R100, which is R0 into 1 plus 100 alpha plus 100 square. So this is the equation, R0 into 1 plus 100 alpha plus 100 square beta minus R0. Okay, R100 minus R0 into 100. So here what we'll do, we'll take R0 common in both the numerator and the denominator. So numerator we have R0 into 1 plus 50 alpha plus 50 square beta minus 1 by R0 1 plus 100 alpha plus 100 square beta minus 1 into 100. R0 gets cancelled. Here 1 that gets cancelled, minus 1 minus 1. So we have 50 alpha plus 50 square beta by 100 alpha plus 100 square beta into 100. So here when we substitute the values of alpha and beta, where alpha is 3.8 into 10 to the power minus 3, beta is minus 5.6 into 10 to the power minus 7. When we substitute these values and calculate, we get this as 50.4. So it is 50.4 degrees Celsius, the temperature reading. Now it is given in the question, if you read the question, it is given that what will be the reading when it is placed in a liquid maintained at 50 degrees Celsius. So the actual temperature is 50 degrees Celsius, but the reading of the thermometer is 50.4 degrees Celsius. So this 0.4 degrees Celsius, it's a deviation, an error. Like every instrument is not 100% accurate. So because of these factors alpha and beta, the temperature coefficients of resistance, there is this deviation from the actual value. So the reading of the platinum resistance thermometer is 50.4 degrees Celsius. Okay, so this is the thing. So here is another question on temperature measurement and temperature scales. So it is given that a thermometer, a random thermometer, it is calibrated according to a linear scale. It reads a value of x0, so the scale is unknown, which scale it is. So it reads a value of x0 when it is brought in contact with boiling water, and it reads x0 by 3 when it is brought in contact with ice. Now when it is brought in contact with an unknown object, a certain unknown object, it reads x0 by 2. What is the temperature of that unknown object in degree Celsius? Okay, so here there are two things. First, we have an unknown scale, and then we have the final result, which is asked in Celsius scale. So we have to perform conversion in between these two. So let us just compare the two. So let's say this is the scale. We have a lower fixed point and upper fixed point. Lower fixed point is generally ice point. Upper fixed point is the steam point or the boiling point. Now, lower fixed point in Celsius scale, it is 0 degree Celsius, and upper fixed point, it is 100 degrees Celsius. Now, according to this unknown scale, okay, according to this unknown scale, when it is brought in contact with ice, it reads x0 by 3. So its lower fixed point is x0 by 3. And when it is brought in contact with boiling water, it gives a reading of x0. So its upper fixed point is x0. Now, when it is brought in contact with an unknown object, it reads x0 by 2. Let's say here. So we have to determine what is the temperature at this point in Celsius. Okay, that is our objective. So here we have to perform interconversion between two scales. So you know the basic formula we have discussed. So the basic formula again, let's say I will repeat. Let's say we are performing this interconversion between two scales. So temperature in one scale, specific temperature in one scale, minus its lower fixed point temperature by the upper fixed point temperature in that scale minus the lower fixed point temperature is equal to the temperature in the second scale minus its lower fixed point by its upper fixed point temperature and the lower fixed point temperature. Okay, this. Now here we have the unknown scale and we have the Celsius scale. So this interconversion, it will look something like this. So here the object, the specific temperature which we want to calculate of that object here, its temperature in this scale, the unknown scale, is x0 by 2. So we'll put x0 by 2 here minus the lower fixed point temperature, which is x0 by 3, by the upper fixed point temperature of this unknown scale, which is x0, minus the lower fixed point, which is x0 by 3. This is for the unknown scale. Then we'll equate it with the Celsius scale. So what is the equivalent of this x0 by 2 in Celsius? That is, let's say we have to determine, so let's name it Tc. Then the lower fixed point in Celsius is 0 by upper fixed point 100 minus 0. Okay, so now we have to make the calculations. That implies here take LCM 3x0 minus 2x0 by, here it is 3x0 minus x0 by 3, that is equal to Tc by 100. that implies x0 by 6 divided by 2x0 by 3 is equal to Tc by 100. So I'm taking it here on this side, okay? I'm taking this side. That implies x0 by 6 into 3 by 2x0 is equal to Tc by 100. x0 x0 gets cancelled. 3 6, that's 2. That implies 1 by 4 is equal to Tc by 100. That implies temperature in Celsius is equal to 100 by 4, which is equal to 25 degrees Celsius. So the temperature of that unknown object in Celsius, it is equal to 25 degree Celsius. That is the temperature. That is the answer. This. Okay. So the temperature of that unknown object in Celsius is 25 degree. Okay. So this is the solution. So simply we have performed the interconversion between the unknown scale and Celsius scale. So here the critical point is to understand this, first of all remember this formula, then be very clear about the upper fixed points and lower fixed points of the different temperature scales. In case of Celsius, it is 0 degree for lower fixed point, 100 degree for upper fixed point. Okay, this.